Welcome back, guys. Let's move on to the next section here. So we've been working on definite and indefinite integrals, but we're going to go back to indefinite ones of a little different variety. So in this section, this is called the substitution rule. And the first question to kind of get you thinking is this one, the integral of 2x square root of 1 plus x squared dx. Give yourself 30 seconds, try to solve this one, pause the video, whatever. Okay, hopefully you paused it, gave it a shot. If not, you should realize I don't know how to do this. We don't know how to do this right now, which is going to introduce us to this substitution rule. So the substitution rule as follows is, if u equals g of x is a differentiable function whose range is an interval I and f is continuous on I, then the integral of f of g of x times g prime of x dx, that should equal the integral of f of u du. Just reading that back, you're probably still confused. This is one that is best done via examples. So let's look right back at the one we just kind of thought about down here. I got two of them up here, but we're going to stick with this one. So this is all about finding something to kind of change this integral that we have here into one that's more manageable. So that's where we get into this substitution rule. So I'm going to pick u here. Tends to be the function within a function. Notice 1 plus x squared is within this square root. So I'm going to pick 1 plus x squared there. I am now going to take the derivative of both sides. The derivative of u is just du. The derivative of this side is going to come to 2x with respect to x, right? The derivative of u is really 1, but I wanted to let you know it's with respect to u. The derivative here is 2x, it was with respect to x. And if we're continuing with this question, that would then be an integral of 2x, the square root of u, right? We substituted that in, and we have this dx here. Our issue now when trying to solve this integral is that we're integrating with respect to x, but we have x's and u's intermingled here. Not ideal. So we'd like to rewrite this 2x and dx and make them all in kind of u world. Notice 2x dx is exactly what we're left with here. So we know 2x dx is the same thing as du. So I can rewrite this integral as the square root of u du, right? That's the substitution we can make again. This now becomes a really straightforward integral. U to the 1/2 becomes u to the 3/2 times 2/3.
This drill is to help you be prepared in case there's a real
Oh, I just can't avoid this. You can't avoid it either. Even via these videos, you get to go through the lockdown with us.
You can share to help keep yourself, your teacher, and your classmates safe. Thank you.
We can then say, since this is indefinite, we need this plus c. However, this answer is wrong because we started in x world. So our answer here needs to end in x world. So this u, we said, is equal to 1 plus x squared. It's to the 3/2 plus c. Let's try this with another question. Over here, we need to find a u. Yet again, this thing is looking really kind of complex. It's not like a basic easy integral. So our u is typically the thing within the function within a function. Here, it's x to the 4th plus 2x. If I take a derivative on both sides, that's just 1, but it's with respect to u. The derivative over here is 4x to the 3rd dx, right? Because the derivative of 2 is nothing. So if we're rewriting this, it's x to the 3rd cosine of u dx still. So we need to hopefully get rid of these x's we're thinking here. Notice we have an x to the 3rd and a dx here. But that's not quite what we have over here. Oh my God, it's never ending.
This concludes the lockdown drill, teachers. We're back to business as usual. Thank you for your cooperation and efforts to make sure we stay safe. Thank you.
So here, since I wanted an x to the third dx, I can divide this 1/4 over. So I know if I'm substituting this x to the third dx in for this underlined red portion, it only costs us 1/4 du. So I need a 1/4 here. The cosine u is still there. And then the du pops over. Okay, pretty straightforward integral here. The 1/4 still there. Cosine goes up to sine. And we have to remember our plus c since it's an indefinite integral, right? There's no bounds. Once we're here, we know u is the same as x to the 4th plus 2. So one quick substitution to get us back into x world. And we've got our answer. What's great with any of these, like if you took both of these and just took a derivative of them, you are going to get back to what we're looking for that antiderivative. Let's try, I have a couple more out here. I don't know if I'll do all of them. I don't want the video to run too long, but I definitely want to do at least these next two. So here, looks like a pretty basic function. Maybe you think you can integrate it, but we kind of get stuck a little bit in just trying to do that. If we pick a u substitution here, yet again, pick a function within the function. That's going to be 2x plus 1. Take a derivative on both sides. Okay, let's put that in. We have an integral, the square root of u. But notice we're still in kind of this x world here, and we need to change it to u world. Well, since dx is the only thing we have here that we need shifted, we need just a dx over here. If we divide by 2, we can now substitute that in. It's 1/2. U is to the 1/2 power, and the du is here. Straightforward integral now, u to the 3/2 power. If we're bringing that down, that's going to be what, to the 1/3, we're really thinking. And we have a plus c. Close to the right answer, but we need to substitute back in the 2x plus 1. Great. You may be looking at the next question and saying, isn't that literally the same thing? Yeah. But with these u substitutions, what can make them great and challenging is that there could be more than one u. This may seem a little asinine, but I'm going to say u is just this whole thing, 2x plus 1, and I'm going to write it to the 1/2 power, right, to include that square root. So I'm thinking we just have a u sub there, right? That's u dx. Not great that we're still in x world. Let's take our derivative over here and see what's happening. Du should equal 1/2. This is going to be 2x plus 1 to the negative 1/2, and here is a dx. So you may be looking here and thinking, maybe I really want to write this as du equals, how do I want this? 1 over 2 square root of 2x plus 1 dx. And in fact, I can even move this 2 over 2 du equals. And we're not even quite there. We really need that one more move here. Sorry, I should have done that in 1. So we know our dx, which is all we want to get rid of, is equal to 2 times the square root of 2x plus 1 du. If we're subbing that all in, 2 square root of 2x plus 1 times u times du. And you may be thinking, well, we made life way worse. We put x's back into our equation, and we did get it in respect to u, but we're stuck with this. But remember, we already said this is equal to u. So that's 2 u du, which is really 2u squared du. I'm quickly running out of room here, but we're going to get there just fine. We're going up to 3. Should be 2/3 u to the, third here, plus c. We're putting this all back in, and we're getting 2/3 2x plus 1 2d. This will be 3/2 because that's 3 over 2 plus c. Did I make a mistake on the first one or the second one? I must have made a mistake on this one. There's no 2 there. Why is this 2 still here? This should be a 1. I can reassess this in class. Our video is already running 10 minutes, so I'm not going to get to these two because I don't want us to be too long here. But our homework here, we're going to be looking at 7 through 31 odd. Don't want to make this video too lengthy for us. If you want to go through these two as well, just to give you a little heads up, our u there is going to be 1 minus 4x squared, and our u here is going to be 5x. Okay, we should still be able to complete the 7 through 31 odd. We're in section 5.5. Sorry it ran a little long here today on the video. I'll blame the announcements and the lockdown. Okay, enjoy your weekend. I'll see everyone back here on Monday. Bye, guys.